Welcome back to G Fun Facts Online. Today, we are going to dismantle the image of the Earth you hold in your mind. When you picture our planet from space, you see that familiar blue marble, perhaps swirling with white clouds, suspended in a dark, empty void. But we are going to travel back in time to prove that this image is not permanent. We are going to a time when looking up from the surface of the Earth would have revealed a spectacle of cosmic grandeur, a feature we usually associate with the gas giants of the outer solar system. We are talking about the newly discovered probability that Earth, for millions of years, possessed a colossal, majestic ring system. This is the story of the Ordovician Ring. To understand this, we have to go back 466 million years. Let us set the scene. You are standing on the shores of a primordial ocean. The air is thick, warm, and rich in carbon dioxide. The land behind you is a barren landscape of red dust and rock because the great forests have not yet evolved. But if you look at the sea, it is teeming with life. Trilobites, nautiloids like shelled submarines, and the very first ancestors of vertebrates. But the most shocking thing is the sky. Arching across the heavens, bisecting the day, and glowing with a ghostly light at night, is a massive ring. It looks like a bridge, made of diamond dust and rocky shards. It spans the horizon, casting a broad, dark shadow across the equator. This isn't science fiction. In 2024, a team of researchers led by Professor Andy Tompkins at Monash University proposed this theory to solve a geological mystery that has puzzled scientists for decades. For a long time, geologists noticed two very strange things about the Middle Ordovician period. First, there was a sudden, violent spike in meteorite impacts. Second, despite the planet being a greenhouse world full of CO2, it suddenly plunged into a baffled global deep freeze. The new theory suggests these two mysteries are actually one and the same. Earth captured a passing asteroid, tore it apart, and wore its remains as a ring. Let's dive into the detective work, because this is where the science gets truly fascinating. The story begins in the limestone quarries of Sweden. Workers there have recovered over 100 fossil meteorites embedded in the ancient seabed. These aren't just random rocks. They're almost exclusively L-chondrites, a specific type of stony meteorite low in iron. To find such a massive concentration of just one type of space rock suggests a single massive event, the disruption of a huge parent body. For years, scientists thought this was just a random shower from the asteroid belt. But Professor Tompkins and his team found a flaw in that idea. If asteroids were raining down from the belt between Mars and Jupiter, they should hit the Earth randomly. They should pepper the globe at all latitudes. But they don't. The team analyzed 21 confirmed impact craters from this specific time period. These craters are found today on continents as far apart as North America, Europe, and Australia. But remember, the continents move. Using advanced plate tectonic reconstruction models, the researchers rewound the clock to where these land masses were 466 million years ago. The result was a statistical shock. When mapped onto the ancient globe, all 21 craters lined up in a neat, narrow band along the equator. Specifically, they were all within 30 degrees of the paleo-equator. To understand how unlikely this is, consider that during the Ordovician, about 70% of the land capable of preserving a crater was located outside this equatorial band. If the impacts were random, most of them should be in the high latitudes. The probability of 21 consecutive impacts hitting only the equator by pure chance is approximately 1 in 25 million. It is a smoking gun. The rocks weren't coming from deep space. They were falling from orbit. So how does a planet get a ring? It comes down to gravity and a concept called the Roche limit. Around 466 million years ago, a large asteroid, estimated to be about 150 kilometers in diameter, had a close encounter with Earth. It passed within the Roche limit, which is the distance where a planet's tidal forces become stronger than the gravity holding the asteroid together. The Earth essentially grabbed this mountain-sized rock and tore it apart. The debris didn't fall immediately. Instead, it was captured into orbit, grinding down into dust and rock and flattening into a disk aligned with the equator. Unlike Saturn's rings, which are made of ice and shine bright white, Earth's ring was made of rock and dust. It would have been darker, perhaps reddish-gray, like the surface of the moon. But from the ground, it would have been spectacular. At the equator, it would be a thin line directly overhead. As you traveled north or south, it would broaden into a wide arch. During the day, it would glitter where the sun caught the fresh fracture faces of minerals. At night, it would glow like a pale, dusty rainbow, illuminated by the sun even when the surface was in darkness. But this ring was not just a decoration, it was a weapon. The formation of the ring began an era of bombardment. The ring was in a decaying orbit. Atmospheric drag and the gravitational pull of the moon constantly knocked material out of place. For millions of years, Earth experienced a continuous rain of shooting stars and larger rocks. This explains the abundance of chondrite meteorites found in Sweden. The sky would frequently streak with fireballs. This bombardment might have actually helped life. The Middle Ordovician saw the Great Ordovician biodiversification event. Some researchers hypothesize that the stress of a changing environment, combined with the influx of extraterrestrial minerals acting as fertilizer, accelerated evolution. However, the ring had a more sinister effect than just falling rocks. It cast a shadow. This is the profound connection to climate science. The Ordovician period ended with the Hernansian glaciation, one of the most severe ice ages in history. This has always been a paradox, because CO2 levels were high. Why did the world freeze? The answer is the ring. Because it was parked around the equator, the ring acted as a solar shade. In a greenhouse world, the tropics are the engine that distributes heat to the rest of the planet. If you place a ring of dust around the equator, you block sunlight from hitting that critical area. The dust from deorbiting material in the upper atmosphere would also reflect sunlight back into space. As the tropics cooled, the global heat transport system faltered. Ice sheets began to grow on the southern supercontinent of Gondwana. As the white ice expanded, it reflected even more sunlight, locking the planet into a freeze. This triggered the late Ordovician mass extinction, wiping out nearly 85% of marine species. It is a terrifying concept, a celestial accident that literally shadowed the Earth, turning a tropical paradise into an icehouse. The ring likely lasted for about 20 to 40 million years. Rings around rocky planets are unstable. Our large moon exerts significant tidal forces that would tug and warp the ring, eventually causing it to dissipate. Much of the material crashed down, creating the craters we see today, while some was flung out into space. As the ring crumbled and the sky cleared, the sun shone with full intensity again, and the ice sheets retreated, ushering in the Silurian period. This discovery changes our perspective on Earth's history. We usually think of rings as unique to gas giants, but we now know they can happen to terrestrial planets too. Mars is expected to develop rings in the distant future when its moon Phobos disintegrates. This implies that rings are a standard phase in the life cycle of planets, usually following a catastrophic capture event. It forces geologists to look at the rock record with fresh eyes. Were there other rings? Some suggest a smaller ring formed around 35 million years ago. Could the ancient snowball Earth events have been triggered by even more massive rings? It also links the history of life strictly to the cosmos. Evolution is not just a response to volcanoes and drifting continents. It is driven by the mechanics of the solar system. The fish that evolved in the Silurian, our ancestors, might owe their dominance to the ecological void cleared by the ring extinction. In a sense, we are the children of the ring. So the next time you look at a picture of Saturn and marvel at its beauty, remember that you are standing on a world that once wore the same crown. For 40 million years, the nights were brighter, the days were dimmer, and the sky was a canvas of moving stone. The 21 craters near the equator are the scars of that encounter, a geological Morse code that has taken us nearly 500 million years to decipher. We may not see the ring today, but its legacy is written in the stone beneath our feet. Thank you for listening to G Fun Facts Online, where we uncover the deep history of our world.